Okay, so picking back up where we left off in lesson 2.5. And I I'm trying to have example 2 showing here. Because example 3 is doing the same thing. Okay? So, example 3 asks us to write a polynomial function of minimum degree in standard form with real coefficients whose zeros include x equals 1, x equals 1 plus 2i, and x equals 1 minus i. So, something we've done in both the last 2 lessons, if you recall from Friday. We did this in lesson 2.3, we did this in lesson 2.4, except the differences. First of all, they usually told me what degree. So they tell me, like, write a cubic or write a quartic. I think you had write a cubic on the quiz, right? And then we didn't have any i's, did we? Okay, throwing those complex numbers in is the new twist. So, with that in mind, thoughts on where to begin here? And I will point out that in the end, we're going to have to go for standard form. Okay? And then real coefficients is what we're told. So, what do you guys remember? I'm going to start with f of x equals. Okay, because they're asking me to write a function, which I will tell you, a lot of you did not put that on the quiz. When you had to write a cubic, I think it was on the quiz, a lot of you did not put f of x equals. You just wrote the expression. So I did not count off on it. But when it's asking you to write a function, I would start it off as f of x equals. So, most people did not put the f of x. I don't remember actually who did and did not, but most people did not put it. So, okay guys, what do we start with? Okay, x minus 1. Says the person who wasn't even here on Friday. Where are the rest of you? Okay, so right here, if it says x equals 1, how do we express that? We're going to express that as x minus 1. Okay. What's next? No? Yeah. Okay. So it's going to be x, and we have to subtract 1 plus 2i. Now, if you guys, and more for the benefit of those who weren't here, on Friday, notice that the first time I wrote it through as I wrote it out as x minus the quantity 2 minus i. But what did that really become? Distribute that negative, it became x minus 2 plus i. On this one, I wrote x minus the quantity 2 plus i, which really became x minus 2 minus i. I did that as kind of the intro. I don't know that you need to do that every time. Okay, so what do you guys want to write? If it's 1 plus 2i, minus 1 minus 2i, so we're already applying the subtracting. Okay. He says x minus 1 plus 2i. What's he doing there? Yeah. Remember, we have to use the conjugates. That was the big trick. Up top, we had the complex conjugate zeros theorem. If you have a complex number, such as 1 plus 2i, then we have to use the conjugates. The conjugate of 1 plus 2i is 1 minus 2i. So that will be a pair that we'll have to use. So this one, x minus 1 and plus 2i. Okay. What else? My next one is 1 minus I, so how do we express that? Okay. Minus 1 plus I, because we're changing those signs. Am I done? Okay, we need the conjugates. So the conjugate of 1 minus I is 1 plus I. So how do I write that in my parentheses? Yeah, x minus 1 minus I. If it helps, guys, I'll put at least 1 up here. That's what we're doing, okay? It's x minus the quantity, and then we are essentially distributing that minus. Can't get this how I want it. Okay. Do we get to stop here? We wish. What do we have to do? A whole bunch of multiplication, right? A lot of big time foiling. Now, what's my recommendation? What's going to make life as
line down the middle.
Okay, do your pairs together. Okay, so start off doing your conjugates. If you're multiplying your conjugate, we're going to get rid of our i's all in the first pass through. Which means this x minus 1 is just going to stay right now. We're just going to carry it down. We're going to do the 1 minus I, 2i, and 1 plus 2i. And we'll do the 1 minus I and 1 plus I. So worry about those conjugates. Now, I would say there's going to be a lot of terms here, yes? Write small. Or just take up multiple lines, however. I mean, you have the rest of the page to finish this problem. So, my x minus 1 carries down. However you want to do this, I tend to take one thing from the first, multiply by everything in the second, right? So x times everything is going to be x squared minus x plus 2ix. Now multiply everything in the next parentheses by negative 1. Minus x plus 1 minus 2i. Now multiply everything by negative 2i. Minus 2ix plus 2i minus 4i squared. That's my first set. Now you can either clean that up or you can go ahead and multiply the next set. I'm going to go ahead and multiply the next set and then I'll have a bunch of cleanup to do. Same process. X times everything, so x squared minus x minus ix minus 1 times everything. Minus x plus 1 plus I. And then I times everything plus ix minus I minus I squared. Now what? Do some cleanup. My x minus 1, I'm just going to carry down. Okay, let's see. X squared should stay x squared. What do you see here? Minus x, minus x. Is that it? So minus 2x. Plus 2ix cancels with minus 2ix. While I'm at that, minus 2i cancels with plus 2i. All of your regular i's should be canceling. And now I have a plus 1 and a minus 4i squared. What do you know about minus 4i squared? It's plus 4. So plus 1 and plus 4 becomes plus 5. Clean up the next one. Yeah, x squared should stay. Minus x should be minus 2x again. minus ix plus ix canceled, plus I minus I canceled. I have a plus 1. And what do you know about minus I squared? It's minus negative 1, so it's plus 1. A plus 1 and a plus 1 is a plus 2. Good news? We've got all the i's gone, right? Not factor, but FOIL, distribute, multiply. Okay, your choice at this point. I'm done with conjugates. I'm done with my imaginaries. We're all talking real coefficients here. Your choice as to what you multiply next. Okay? I personally was going to do the 2 big ones. I'll get those done. I mean, honestly, it honestly doesn't matter. As long as you don't make a mistake, we're all going to end up in the same place in the end. Okay? So I honestly was just going to carry my x minus 1 down. I guess I'm saving the easier piece for the end. And work on the 2 trinomials. So x squared times everything. X to the 4th minus 2x cubed plus 2x squared minus 2x times everything. Minus 2x cubed plus 4x squared minus 4x. 5 times everything plus 5x squared minus 10x plus 10. Carry down the x minus 1. Some cleanup. X to the 4th stays. What do I have? Minus 4x cubed. Yeah. 6x, 2, 4, 5, so 6, 11x squared. Minus 4x minus 10x is going to be minus 14x, and then plus 10. Almost there, really. The easy stuff is left. Okay, so now it's x minus 1 times everything. So x times everything and then minus 1 times everything. So x to the 5th minus 4x to the 4th plus 11x to the 3rd minus 14x squared plus 10x. I just increased the x's on everything by 1. And then it's minus 1 times everything. Minus x to the 4th plus 4x cubed minus 11x squared plus 14x minus 10. Okay, x to the 5th, got that. Minus 4x to the 4th minus x to the 4th, so minus 5x to the 4th. 11 and 4, 15x cubed minus 25x squared plus 24x minus 10. Good news is it matches my notes. Okay, I'm going to throw in an f of x equals, because we are being asked to write a function. And there you go. Should I see some work on these? I mean, if you want full credit for your homework tomorrow, I would expect to see an appropriate amount of work. I'm not really sure how you could have skipped many of these steps. I mean, I don't know. I know some of you guys try and do a lot in your head, but I'm not sure there's a whole lot of that we could have done in our heads. So, okay. Got the idea? Those of you who were here, did it come back from Friday a little bit? Those of you that weren't here, you're getting here now? It's getting there now? Okay. Key is that complex conjugate zeros theorem. You always have to have conjugates. Okay, on the back side. Different thing here. We are being asked kind of to go the opposite direction. Okay? On the front side, we were given some zeros. We changed them to factors, and then we had to go to standard form. Here, we're given standard form, and we're being asked to find all of our zeros. Okay? So, example 4 says find all zeros of this given function and write f of x in its linear factorization. In all honesty, we've done bits and pieces of this. May not realize it because it's different vocabulary, different what they're asking us to do. But we did a little bit of this back in lesson, 2-4? Right there before the quiz. Okay? So, a couple of things. First of all, it says to find all zeros. How many zeros should I end up with in the end? 5? 5 because it's a fifth degree problem, yes? In lesson 2-4, it could be a fifth degree problem, but we didn't always end up with 5 because we could only find the rational zeros and the irrational zeros. Now we get to find the imaginaries too. So now, if it's a fifth degree problem, there will be 5 zeros. Okay? Some real, some imaginary. Okay. And write f of x in its linear factorization. Okay, so linear factorization, we will be factored out. Now, do you remember how we went about starting these problems? Okay. Okay, so I heard 2 things here. Synthetic division and the possible rational roots or potential rational roots are PRRs, right? Now, I'll let you off the hook. If you don't want to write PRRs out, that's okay. Can you kind of guesstimate, though? I mean, you kind of have an idea of what PRRs are. And I'll kind of throw them up here. I'm not going to get as official here as I did. But, reminder, focus up here, please. How do we do PRRs? Okay. Factors of 8 over factors of 1. So what are factors of 8? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. What are factors of 1? Plus or minus 1. Okay. So, again, I'm not going to make you go all the way through and write those out because you guys can visualize those, right? You see the 8 and you know it's over 1. You can come up with, okay, it's 1, 2, 4, 8. I know those basic numbers. Now, what do we do before we start into synthetic division? We graphed it to give us an idea of where to start, right? And I did forget where you had this graphing part, but you'll be fine. So, if you would, work on getting it graphed. I would recommend, and I've said this to some people, before you actually hit graph, and this is especially true on a quiz or a test, it doesn't hurt to just double check if you type in the right thing. Because if it's on a quiz or a test and you type in the wrong thing, can I see what you typed in? I can't. So it makes it hard for me to give you any partial credit. So, okay. So we're looking for plus or minus 1, 2, 4, and 8. You think some of those might happen? Which ones might we try here based on our PRRs and based on our graph? -2, 1, and 4. Now, you guys just gave me 3. What's that say about the others? Okay, we're going to have a pair of imaginary ones. And remember, irrationals occur in pairs, imaginaries occur in pairs. And so we're going to have a pair of imaginaries. So I'm going to write down the fact that the graph suggests x equals -2, 1, and 4. So what do I do now? Synthetic division. Doesn't matter which one I start with. Nope. Pick one. It doesn't matter. We can do them in all different orders. We'll still be okay. We'll still meet up in the end. I'm going to start with -2. What do I use with my -2? Okay, 1, -3, -5, 5, -6, 8. You guys got your synthetic division under control here? Drop the 1, multiply, add, and repeat. -2 times 1, -2. That adds to be -5. Multiply. 10. Add. 5. Multiply. -10. Add. -5. Multiply. 10. Add. 4. Multiply. And add. 0. Is that good news? Yeah, that's good news. The negative, we had a remainder of 0, which means -2 works. We kind of expected that. Now what? Okay, it is incredibly important. You have to, and majority of you guys did on the quiz, but you have to carry over your new set of numbers. It is impossible to find your imaginaries if you don't carry over your new set of numbers. Okay, so we have to here. So, this time, doesn't matter, just pick another one. So if we try 1, and this time we're going to use 1, -5, 5, -5, 4. Drop the 1 and start your process, right? 1 times 1 is 1. Add. -4. Multiply. Add. Multiply. Add. Multiply. And add. Remainder of 0. Okay. So we know 1 works, which again, what we expected. And now, this time we're going to use 4. And we're going to use our new set of numbers. 1, -4, 1, -4. Okay. Bring down the 1. 4 times 1 is 4. -4 plus 4. 0. 4 times 0. 0. 1 plus 0. 1. 4 times 1. 4. -4 plus 4. 0. Again, remainder of 0. That means 4 works. Okay, so it wanted linear factorization, right? We have 3 zeros, so we can write those as factors. We need a total of 5. This is where, what do these remaining 1, 0, 1 mean? This is 1 x squared plus 0x plus 1. And if you're not sure, just go back and think. Okay, this was x to the 5th, yes? Now it became x to the 4th, x to the 4th. Then this becomes x to the 3rd. Carried over, x to the 3rd. Now it becomes x to the 2nd. So this is represented as x squared plus 0x plus 1, and we're going to set that equal to 0. How do you solve x squared plus 1 equals 0? Subtract 1. So x squared equals negative 1. Take the square root. And then, what is the square root of negative 1? I. And then when you're in an equation, plus or minus I. Okay. Do I have 5 zeros now? The 3 we used with the synthetic, the 3 we saw on the graph, and then a positive I and a negative I. So, final answer. F of x equals, we want a linear factorization. So, negative 2. What does negative 2 represent as a factor? X plus 2. Then we have 1. What does 1 represent as a factor? X minus 1. Then we had 4. What does 4 represent as a factor? X minus 4. Then we had I. What does I represent? X minus I. And then we had negative I. X plus I. Yes? You cannot, because it needs to be written as individual factors. So, if you're just giving me the answer like x equals, like what I did over here, yes. But in terms of factors, you need to write the individual factors. Okay. Similar process to what we've done, right? And again, I stressed at the time, you have to go through and use those numbers and keep adjusting because we're factoring it down. And by factoring it down, we were able to find our imaginary roots. Okay, one more to try. And that is example 6. The complex number z equals 1 minus 2i is a 0 of this equation. Find the remaining zeros and write f of x in its linear factorization. Okay. How many zeros are there going to be altogether? 4? We know because it's x to the 4th that there are going to be 4 zeros. What did they already give us? They gave us 1. They gave us 1 minus 2i. Think. If we know 1 minus 2i, complex conjugate zeros theorem says we also know 1 plus 2i. So even though they only wrote down 1, they really gave us 2. Okay? Now that means we have 2 more to find, doesn't it? Okay. PRRs, you can think about PRRs. I'm going to check out the graph for you though. Okay, so you can think about PRRs. Okay, that is our lovely graph. Okay, nothing graphed on my 10 by 10 screen. I forget if Zoom Fit will do something for me. Zoom Fit is option 0. Let me see if Zoom Fit does something for me. I forget. Okay. I don't know if Zoom Fit does a whole lot there. Yeah. Okay, so it kind of shows a big, like, parabola or quartic shape. Notice I hit trace, and what value is that showing? 0.65. So, are you getting where I'm going with this? Yeah. Is this going to cross the x-axis? No. Do I have any real number zeros on this one? No. I'm going to have 4 imaginaries, or 4 complex numbers. We already know 2 of them. We're going to be able to find the other 2. Okay, so let's see. They gave us that 0. We have to find the remaining zeros and write the linear factorization. Because I can almost guarantee I'm going to forget something I probably should have mentioned earlier. Notice on this problem there is an A value, yes? Okay. Keep that in mind. Because what that is that is a lead coefficient, right? In order to get your lead coefficient in the problem, we're going to have to carry it down there by hand. Okay? We're going to find all these factors, these 4 zeros that lead me to my 4 factors. But we have to remember to carry that A value down by hand. I say I'm going to forget because did I even mention it on the previous problem like I should have? No, I forgot. So I'm trying to mention it while I remember. So when we get down to the end, we'll write our 4 factors and we'll have to put that 4 out front. So, okay. What do we start with? There's no graph suggest, but we have 1 minus 2i, yes? We're doing synthetic division with 1 minus 2i. I would, as you write out your line of numbers, I would leave some spacing. Okay, I wouldn't put everything on top of each other necessarily. Okay, so follow along, please. Did you give me the easy part of drop the 4? Hey, some of it's not too bad. So then it's 4 times 1 minus 2i. 4 minus 8i. Easy enough? Add the 0, and now we're still at 4 minus 8i. Now, 1 minus 2i times 4 minus 8i. How do I multiply 1 minus 2i and 4 minus 8i? You have to FOIL them. Okay, so I'm going to kind of come down here, and I'm going to have a work section. Because I'm not going to try and FOIL all this in my... I mean, I can FOIL it in my head. However, I want to make sure I don't have someone saying, whoa, where'd that all come from? So, 1 minus 2i times 4 minus 8i. Making fun of me back there.
Whoa, where'd all that come
Okay, FOIL it, guys. 4 minus 8i minus 8i plus 16i squared. What's that all clean up to be? There's a 4 plus 16i squared is minus 16. So 4 minus 16 is negative 12. Negative 8i, minus 16i. So that's going to go up under the 17. Negative 12 minus 16i. Now we're ready to add. 17 adds to negative 12, and that's going to be 5 minus 16i. And now, FOIL again, because now we're doing 1 minus 2i times 5 minus 16i. 5 minus 16i minus 10i plus 32i squared. Work with me here. I've got a 5 plus 32i squared is going to be 5 minus 32, minus 27, and then minus 16i minus 10i is going to be minus 26i. Where's that go? Under the 14. And now we add again. 14 and negative 27 is negative 13 minus 26i. And one more time, we need to FOIL. So it's 1 minus 2i times negative 13 minus 26i. Okay, FOIL. Negative 13 minus 26i plus 26i plus 52i squared. What's happening on this one? Yeah, my middle i's cancel. Negative 26i plus 26i cancel. Negative 13 minus 52 minus 65. 65 plus negative 65 is 0. But it actually worked. I mean, that's half the battle there, yes? And the thing is, since it worked, I can feel pretty confident that these pieces are right. So now what? Now we have to do the conjugate. So we already tried 1 minus 2i. I don't know. Now we have to do 1 plus 2i. Carry your new numbers over. 4 minus 8i. 5 minus 16i, and negative 13 minus 26i. Yes? You have to do this to be able to find our other 2 missing zeros. Nope. Okay. Drop the 4. Okay, guys. This one's a lot easier. 1 plus 2i times 4. 4 plus 8i. What happens when I add? 4 and 4 is 8. My i's cancel. Now it's 8 times 1 plus 2i. 8 plus 16i. 5 and 8 is 13. I's cancel again. Now it's 13 times 1 plus 2i. 13 plus 26i, and everything cancels. We know 1 minus 2i works. We know 1 plus 2i works. What are my remaining pieces? 4x squared plus 8x plus 13. Set that equal to 0. Guys, we know there's imaginary zeros coming. Is this going to factor? No. What are we going to have to use? Quadratic formula. So, it's going to be negative b, so negative 8 plus or minus the square root 8 squared minus 4 times 13 all over 2 times 4. Okay, I will put the finishing touches on that problem tomorrow. Okay, you are to work through homework. Okay, I don't necessarily expect it to be 100% gradable when we walk in. I understand that I have to put the finishing touches on this problem, but the rest of the problem should be good to go. and I will help you fix this one, which can help you in homework. Page 215, 2 through 36 evens is where you were headed.
Abby.